Good evening.
Good evening, sir.
So, what was the last topic we were discussing yesterday?
So we were solving numericals
So, we were solving it.
based on lens makers only.
So, we were doing lens makers. So, lens makers formula, yes. So, today we will do some more derivations. So, write down the next heading, that is lens formula. So we saw what is mirror formula, right? Similarly, we have something called as lens formula, which gives a relation between V, U, and F. 1 by V minus 1 by U is equal to 1 by F is the mirror formula. Sorry, lens formula. For this, the derivation is going to be something similar to how we derived mirror formula. Okay. So let's say this is focus, this is the center of curvature. This is focus, this is the center of curvature. If an object is placed beyond the center of curvature, right? So if you take a ray parallel to the principal axis, after refraction, where will it pass? It will pass through?
Focus.
Yes, it will pass through the focus. Similarly, if you take a ray through the optical center, it is going to pass undeviated. When this is the scenario, the image will be formed between the center of curvature and the focus. So if this is AB, this is going to be A dash B dash. Correct? Now see, the distance from the optical center to this point is U. The distance from the optical center to this point is P. And the distance from the optical center to the focus is F. Right? So from here, if I drop a perpendicular, this point is O. And if I call this as M. Now listen to this carefully. I need a set of similar triangles, right? For me to start the derivation. So if I take this angle as theta, this angle is also theta, this is 90 and this is 90. So I'm trying to say that triangle B dash A dash O is similar to triangle BAO. Right? According to AA criteria, then B dash A dash divided by BA will be equal to A dash O divided by AO. Let me call this as equation number 1. In a similar way, if I look at this angle, if I say this is alpha, and this angle is 90, and this angle is also 90, if that is the scenario, then B dash, the triangle B dash A dash F is similar to triangle MOF. So B dash A dash divided by MO is equal to A dash F divided by OF, right? But I'm clear with the fact that B dash A dash divided by MO is nothing but, what is MO? MO is numerically equal to AB is equal to A dash F divided by OF. Let me call this as equation number 2. So from 1 and 2, A dash O divided by AO is equal to A dash F divided by OF, which implies, what is A dash O? A dash O is V divided by AO is how much? AO is U with a minus sign is equal to, what is A dash F? A dash F is B minus F divided by OF is how much? It is F, which implies VF is equal to minus UV plus UF. So divide with UVF on both sides. So when you divide it with UVF on both sides, you will get 1 by U is equal to minus 1 by F plus 1 by V. So rearrange the equation, take this to the other side and this one to the left hand side. Then you will get 1 by V minus 1 by U is equal to 1 by F. So is that clear? So 1 by V minus 1 by U is going to give you 1 divided by F.
So can you scroll up a little bit?
Sure. I'm turning the screen. Copy it. You want the diagram or is this fine?
That's fine. Sir, I have one doubt, sir. And not in this, but normally while deriving the formula itself, we use the sign convention, right? So why should we again apply that when we are solving it?
Because, see, during the process of derivation, see, when you take the case of mirror, how many mirrors do you know? You know, plane plus spherical. Again, spherical are classified into two types. What are they? Concave
Convex.
and convex. Right? Plane mirror has one ray diagram. Concave has 6. Convex has 2. So totally you have 9 ray diagrams with respect to mirrors. Correct? So when you have 9 ray diagrams, listen to this. When you have 9 ray diagrams, you derived something called as mirror formula for one scenario. Correct? Now, what about the other 8 scenarios? If you try to derive them without sign convention, what would have happened? If you derived them without sign convention, then you should have got 9 different formulae according to situation. Correct? Nikhil is accepting with this?
Yes, sir.
Right. But you never called it as mirror formula for this scenario. You generally called it as a mirror formula. So in that formula, what you did is by applying sign convention, you created a generalized situation. Correct? By doing what? By applying the sign convention. But while you solve problems, is it a general thing? When you talk about a problem, an object will be kept at a particular location. So it is a specific thing. Correct?
Yes.
So when you're solving the problem, whatever changes you did in the derivation process to generalize the formula, by applying the sign convention again, you're nullifying it. Means you're reversing the process.
Oh.
Got it?
Yes, sir.
So that is the reason why when I say whichever your, see, that is why when I told sign convention also, there are certain cases where I didn't apply sign convention. What were the derivations? If you have observed keenly, you would have known the derivations where I didn't apply sign convention.
I
One
think
was
lens maker.
yes, lens maker's formula I didn't apply it. Why?
Because I think
Because
that's a space. You don't have 9 different shapes.
no, it's not about 9 different shapes because we are not specific about that ray diagram. Correct?
Yeah,
I
yes.
told you, yes, 2 different situations are possible. So whichever you're not specific during the process of derivation, then it becomes a generalized factor. So in that case, so actually refraction at spherical surface also has different ray diagrams. where I tried to show you two different diagrams by taking the comparison. But what happens is, in that case, I didn't apply it because the diagram which I drew during the process of derivation itself was unclear. I don't know where the image is going to be formed. It was our assumption that this image will be formed at this location and it will act as an object for the second refracting surface. So since it was an assumption, there we didn't apply sign convention. Whereas with respect to this diagram, I'm 300% sure that this is where the image is going to get located. So it is a particular case. Correct? So that is the reason why we need to apply sign convention. So have this. Got it? Good. So are you clear with why you're applying sign convention even in problems? Can you tell me why?
Because the specific situation is good.
Yes. So general formula, when you use it for the reverse process, when you're using it for a specific situation, you're nullifying. You're actually doing the reverse process of what you did in the derivation to arrive at the general formula. So that is the reason why we do it. So that is the only logic in this chapter. That is where many students I've seen struggling. They don't know where to apply sign convention or not. Good that you asked it. Yeah. So is this derivation over? Yeah, good. So is this derivation over? Yeah.
Yes, sir.
Yes, good. We'll move on to the next one then. So next we are going to define is the power of lens. So basically, if you take a lens and you want to define the power of it, you would have learned in your lower grades. So power of lens basically tells you the extent to which a lens can converge or diverge the rays approaching it. So power of a lens is basically a measuring parameter. It is some parameter for a lens which will give us what idea? The extent to which that particular lens has the tendency to converge or diverge the rays which are approaching towards it. So let us take an example for. Suppose I have convex lens. Right. So same thing. One is the focus is here, and for the second one, the focus is here. I am considering a ray parallel to the principal axis in both the scenarios. So in the first case, it is going to bend like this. In the second case, it is going to bend like this. Right. So if I extend it, can I call this as the deviation? Similarly, if I extend it here, I'll call this as the deviation. Am I clear? Yes. Tell me, looking at the diagrams, in which case is the deviation more?
First.
Why? Because the focus is closer to the optical. Yeah, closer to the optical center. If that is going to be the scenario, the ray has to get bent more to ensure it is still passing through the focus when it is parallel to when the incident ray is parallel to the principal axis. So if this is delta, this is also going to be delta. Let me say this height is h, then this distance is going to be focal length. Now, if I'm able to define tan delta from this right angled triangle, okay, if I'm able to define tan delta from here, tan delta is going to be h divided by f. And if h is equal to 1, that implies tan delta is equal to 1 by f. And this is what is called as
power
of. So what is going to happen is tangent of the angle of deviation for a ray which has hit the mirror, hit the lens at a distance of how much value? At a distance of
f
1 unit. At a distance of 1 unit from the optical center is what is called as power. So tangent of the angle of deviation when the ray has hit at a distance of 1 unit from the principal axis is what is called as power of lens. So that is the reason why power is defined as 1 by f. It didn't come just like that. So if you need the power to be more, then you need to ensure that the focal length is less. That's what the mathematical equation tells us. Right? Please make a note of it. Done? So what is going to be the unit of power, SI unit of power? This meter inverse, which is in this context called as diopter, which is represented by the symbol. Right, this is what we call it as diopter. So power is equal to 1 divided by F if F is measured in meter, or the same thing can be written as 100 divided by F if it is measured in centimeter. Right? Is that clear? Guys, yes or no? Clear?
Yes, sir.
Okay.
Yes, sir.
Now we need to know, we need to know certain facts that the power, when it is calculated with respect to the different lengths, it changes. We know that the focal length, so this is an important point from your textbook. So suppose you go for an eye checkup and suppose you are prescribed with some corrective lens, then it depends. So if they say the corrective lens power is plus 2.5 diopter, then what is going to be the focal length? Focal length will be 1 divided by 2.5, or it is going to be 10 divided by 25. Right? What is 10 divided by 25? It is going to be 2 divided by 5, or 0.4 meter. Right? When it is going to be, so is it right? 2 divided by 5, 2 divided by 0.4 meter, or this is also equal to 40 centimeter. So they have suggested you a lens. Which lens? They have suggested you a convex lens of focal length 40 centimeter. Clear?
Yes, sir.
Yes, sir.
So having all these points in mind, let's try to solve two problems. Then we'll go to the next concept, that is refraction through prism. So let's try to solve it. If the focal length is 0.5 meter for a glass lens, what is the power of the lens? So power is equal to 1 divided by F. So 1 divided by 0.5 is going to give me 2. So 2 diopter, and it is positive. So it's a convex lens. Right? Similarly, the radius of curvature of the faces of a double convex lens are 10 centimeter and 15 centimeter. They are what? They are 10 centimeter and 15 centimeter, and the focal length is 12 centimeter. What is the refractive index of the glass? So lens maker's formula: 1 by F is equal to mu2 divided by mu1 minus 1 into 1 by R1 minus 1 divided by R2. So focal length is 12. So what is the nature? It's a convex lens. So focal length is positive. 1 by 12 is mu2 is how much, guys? So that's what we need to find. So mu divided by 1 minus 1 into 1 divided by 10 plus 1 divided by 15. Why did I put a plus? Because 10 is positive, R1 is positive, and R2 is negative. So 1 by 12 is equal to mu minus 1 into 25 divided by 150. This will go 6 times and this will go 2 times. So mu minus 1 is equal to 2. Mu will be equal to 3 by 2 or 1.5. So refractive index of that material which they have given is going to be 1.5. Right? Shall I move on?
Yes, sir.
Yes, sir.
Right. So next concept is combination of thin. Oh, sorry, there is another problem, right? There is a convex lens of 20 centimeter focal length in air. What is the focal length in water? So I'll give you 2 minutes time. Try to solve it. I explained this problem yesterday. So try this. There is a convex lens which has 20 centimeter focal length in air. What is the focal length in water? So what is the answer, guys? Answer, guys. So focal length of the lens in air is 20 centimeter. It's a convex lens, so it is positive. So focal length in water is equal to what? Refractive index of air water. So refractive index of water is 4 by 3. Refractive index of glass is 3 by 2, 1.3. Right. So 1 by FA is equal to refractive index of glass minus 1 into 2 divided by R. 1 by FW is equal to 4 by 3 divided, sorry, 3 by 2 divided by 4 by 3 minus 1 into 2 divided by R. So when you divide both, Fw divided by Fa will be equal to mu g is 3 by 2 minus 1. So when you divide both, 2 by R and 2 by R will get cancelled. Mu g minus 1 is half divided by 9 by 8 minus 1. 9 by 8 minus 1 is 1 by 8. So this goes 4 times. So Fw is equal to 4 times Fa. So 4 into, what is the value of Fa? The focal length in air is 20. So it is supposed to be 80 centimeter. So they got 78.2 because they took 1.5 and 1.3. I took fractional values. Right. Next one is combination of thin lenses in contact. So when you place two lenses of focal length, when you place two lenses of focal length f1 and f2 in contact with each other. Okay. Now what can happen is, look at the ray diagram. If an object is placed here, then there is a ray that is going to travel undeviated like this. Right. Secondly, there is a ray which will go and hit the surface here, and it will start, first it will start bending, and there is a possibility that the image is formed at this point. Then this image will start acting as the object for the second refracting surface. Due to the second refracting surface, let's say the image is formed at point I. Now, let me say the initial object distance is u. The first image distance is v1, and the second image distance, the final image distance is v. Okay. So case 1, that is for lens 1. So for lens 1, what is going to happen? If I apply the lens formula, 1 by v minus 1 by u is equal to 1 by f. So 1 by, what is the value of v? V is v1 minus 1 divided by u is how much? U only is equal to 1 divided by the focal length is f1. So now what about lens 2? 1 divided by the final image is formed at v. The final image is formed at v, this part. Okay. Minus 1 divided by the initial object distance is v1 is equal to 1 divided by f2. Now when you add both, what will you get? You will get 1 by v minus 1 by u is equal to 1 by f1 plus 1 by f2. So what is 1 by v minus 1 by u? It is 1 by f effective is equal to 1 by f1 plus 1 by f2. Means what they are trying to say is, if you place two thin lengths in contact with each other, then the effective focal length of both the lengths put together will be equal to, then the effective focal length of both the lengths put together will be equal to how much? Will be equal to 1 by f1 plus 1 by f2. So from this I can conclude that effective power is equal to P1 plus P2. Right. Similarly, if you have n lengths in contact with each other, it will be P1 plus P2 plus Pn. It keeps on going like that. Is there any doubt in these two steps? So these are two important formulae that you need to remember. Any doubt, guys?
No, sir.
Please make a note till this point. Done. Now listen. So what is the magnification produced due to the first lens? M1 will be equal to V1 divided by U, and M2 will be equal to V divided by V1. Then the magnification, the effective magnification will be equal to V divided by U. Why? Final image divided by the initial position. So can I write this as V by V1 into V1 by V? Sorry, V1 by U. So what is V divided by V1? V divided by V1 is M2 into V1 by U. V1 by U is M1. So what happens when two thin lenses are in contact, or when you use combined lens together, right? Then what is going to happen is the effective magnification will be the product of the individual magnifications. Okay, so this is the logic that they use to manufacture cameras, microscope, telescopes, and other optical instruments. Okay, now listen guys. I'll take example 9.9. So in the example 9.9, our job is to find the position of the image formed by lens combination given in the figure 9.2. Okay. So if you see, there is an object O that is placed in front of a lens combination. So F is equal to plus 10 centimeter, minus 10 centimeter, and plus 30 centimeter for each lens. Okay. Now we need to find the image formation due to the whole combination. So what I'm going to do is, I will take the lens one into consideration. I'll find where the image is formed due to it. 1 by V1 minus 1 by U1 is equal to 1 by F1. So 1 by V1 is V1 only, minus 1 divided by U is minus 30 is equal to 1 divided by F1 is plus 10. So 1 divided by V1 is equal to 1 by 10 minus 1 by 30. So it is going to be minus 20 plus 20 divided by 300. So V1 will be equal to 15 centimeter. So what we are trying to say is the image due to the first lens is formed at a distance of 15 centimeter from the first convex lens. So V1 is 15 centimeter means with respect to the first lens, the image is formed at a distance of 15 centimeter, means literally at the optical center of the third lens. Okay. Now, this will start acting as the object for whom? This will start acting as the object for the second lens. But from this optical center, what is the distance of the optical center of the second lens? It is only 10 centimeter. So for lens 2, if I apply the formula 1 by V2 minus 1 by U2 is equal to 1 by F2. So 1 by V2 minus 1 by U2 is how much? U2 is how much? U2 is
15 minus
10. Yeah, 15 minus 5. That is 10.
yes.
This is U2. this is U2 is equal to 1 by F2 is also minus 10 because it's a concave lens. Moreover, it's a plano concave lens, not a concave. Plano concave, and they have given the focal length as minus 10. So this and this will get cancelled. 1 by V2 will be equal to 0, which implies V2 is equal to infinity. Means the image due to the second lens is formed at infinity. Now this image formed due to the second lens will behave as the object for the third lens. Accepted? Yes, sir. Right. So for lens 3, what is going to happen? If you take for lens 3, you need to apply the formula 1 by V3 minus 1 by U3 is equal to 1 divided by F3. So 1 by V3 minus 1 divided by U3 is infinity is equal to 1 divided by F3 is how much? Plus 30. So which implies 1 by V3 is equal to 1 by 30, or that implies V3 is equal to 30 centimeters. So 30 is positive, means the image with respect to the third lens is formed somewhere over here at a distance of 30 centimeters from it on the right hand side. Okay, and this is a very, very, very important problem. I've seen this asked 2-3 times. Okay, ensure you're clear and please make a note of each step that I've written here. Don't look at the solution that is given. Write down the solution that I wrote, and if there is any doubt, get it clarified for me. Don't be lazy or don't take screenshots, write it and get the doubts clarified if at all you have. Okay. Clear? Yeah. So 7, 8. So I have 7 more minutes left. I don't think I can start the next topic. So this is all about lens, and the concept that we are supposed to start fresh is refraction through prism. Okay. So just give me a minute. Don't log off. Just wait for a minute. Just try this problem alone. With that, we can wind up. Do it fast. A lens forms a real image of an object. A lens forms a real image of an object. So when they say lens forms real image, it is by default convex only, because concave lens will never form real image. The distance of the object to the lens is u centimeter, and the distance of the image from the lens is v centimeter. The given graph shows the variation of v with u. What is the nature of lens? What is the
Convex.
nature? Yes, I already told it is convex. So using the graph, find the focal length of the lens. So if you observe, this coordinate is 20, 20. Means what is happening? The object distance and the image distance both are 20. When is it possible? Only when the image is only when the object is placed at C. Correct? Only when the object is placed at C, the image and the image distance and the object distance are same. Okay. When the object is placed at C, that the radius of curvature is also 20 centimeter.
So the
Right. When
focus
the
will
radius
be
of
10.
curvature is 20 centimeter, it will be 10 centimeter. That is why it is plus 10 centimeter. Plus is because it's a convex lens. Okay. Shall we do one last problem? Try this. A needle placed 45 centimeter from the lens forms an image on a screen placed 90 centimeter on the other side. Identify the type of lens and determine its focal length. A needle placed 45 centimeter from a lens. So by default, U is always negative for minus 45 centimeter, unless you know using the ray diagrams from a lens forms an image on a screen placed 90 centimeter on the other side of the lens.
So we can
V is
find
equal
focus from the formula, lens
Yes.
formula.
Yes. Identify the type of lens. Identify the type of lens. So lens is what? Object and
Virtual
image or on
image.
the on virtual is only for mirror. For lens, if the object and image are on opposite sides, it is always a real image.
Yes,
Okay.
yes.
So what is focal length?
Focal length is
1 by 90. No, I didn't get you. Did you ask
no,
anything?
so I was just telling 1 by 90 plus 1 by 45.
So it is 45 into 90. This will go 5 times and this will go 19 times. Correct? 45 3 only. No, 45 3 is this thing. So 45
1 by
3.
18.
1 by 30. 45 plus 30, 90 is 135 divided by 45 into 90. So this goes 3 times and this goes 30 times. So focal length is plus 30 centimeters. So focal length is plus 30 means it's a convex lens and determine its focal length. So f is equal to plus 30
Plus
centimeter.
30.
What is the size of the image formed? Size of the image formed is V by U.
V by U.
The size of
So
the image means
So that will give
height
us a
of-
magnification. So with that,
height of the image. So height of the image by height of the object is V by U. Correct? So V is 90, U is minus 45. Height of the image is what you need to find divided by height of the object is, they didn't give a needle size is 5 centimeter. So 5. This goes 2 times. So height of the image is minus 10 centimeter. Minus indicates that it's a real and inverted image. Is that clear?
yes, sir.
So this is how we solve problems based on lens. Okay. So the next concept that we are supposed to see is what? Refraction through prism, which we will start tomorrow. So there are the topics that are left out are refraction through prism, which I'll complete in one class. After the concept of refraction of prism, we have the concept of optical instruments. Optical instruments, maximum 2 classes. So even if you have a buffer time of 1 more class, in 4 more classes, this chapter will be over. And this is the biggest chapter. After this, all other chapters will be over very fast. Okay, don't worry about it. So concentrate and work on this chapter repeatedly so that the other chapters are easy for you guys. Clear?
sir, can you send the PDF of this, sir?
Yeah, I'll do it. Just give me a reminder. No? I'll do it.
Oh, okay.
Okay. Yeah. All the PDFs I'll send.
Okay.
Or else I'll be uploading. I'll see, depending on tomorrow's thing, I upload it as assignment itself so that you can do it during the course of this week. Okay. that's it from my side, guys. Okay, that's it from my side. I'll see you all tomorrow.
Thank you, sir.
Thank you, sir.